Hi guys and welcome back. Today we're going to take a look at this problem, magnetic force between two balls. And this is kind of a tricky question. It's much easier to read from the examples instead of the statement, the problem statement. So essentially what this problem is asking us is to place our balls into containers that are given to us in the input so that the minimum distance between any pair of balls is maximized. So we want to maximize the minimum distance between every pair of balls. So to do that, we're going to use this Python powerful ultimate binary search template. So you need to memorize this template. I'm going to give you the link in the description. And what this template essentially does is it returns at the end of the loop, it returns the lowest possible value that satisfies a condition. And this is the condition that we're going to have to implement. So when you paste this template into your code, you only need to change three things. You need to change the search space, so the initial left and right variables. You need to change the condition function, and then you need to decide whether or not you need to subtract 1 from left before returning it. So remember, when deciding this, left is going to be the lowest value that satisfies the condition. So in our case, what we are going to do is I just pasted in the code from the template, but in JavaScript instead of Python. And so, well, the first thing is the search space. So from the constraints of the problem, we know that the maximum position is going to be 10 to the 9th. So our largest possible distance that we can have is 10 to the 9. We cannot have any larger distance than that in our position array. And our lowest search space value is 0, because we can't have any distance, negative distance. That's impossible. Okay, so then we're going to have to design a function called cannot place m balls, where m is our input parameter asking us to how many balls we have to place in our positions. So you can see that here I had to subtract from left 1 before returning it. Why is that? Because here the condition is I cannot place m balls. So I'm searching for the lowest value of left such that I cannot place m balls in my positions. So let's say that, for example, the lowest value is going to be 7. The lowest value that satisfies this function is 7. Then I would have to return 6, because with 6 that would be the maximum value that I can use as a distance, as a minimum distance between my balls, so that I can indeed place all of them in the positions given as input. So now the only thing that is missing is to implement this cannot place m balls function, and that's pretty easy. What we're going to do is we're going to start with one ball placed in the first position, and keep in mind that we have sorted all of the position in numerical order. So this is going to be the smallest position. Then we're going to say, okay, this is my search index, and obviously it's 1 and not 0 because I've already used the 0th index. Then we're going to say, okay, how many balls have I placed yet? And obviously we've already placed 1, so we initialize this variable with 1. And at the end, I'm going to say, I'm going to return true if the amount of balls that I've placed is less than m. So cannot place m balls, we return true if the balls that I can place is less than m. If it is equal or greater than m, then I'm going to return false. Okay, so now we just need to update this balls placed variable. And to do that, we're going to use a loop. This is a very common while loop. Just don't go out of bounds and stop early if the amount of ball placed goes greater than m. So remember at each step to increment the index, don't forget that. And then we're going to say, okay, if the current position minus, so if the difference between the current position and the last position is greater than the minimum distance, which is passed as a parameter, then we can place another ball. So the last position now becomes the current position, and I have placed another ball. And that's it. So now the only thing missing is, remember to subtract 1 from the left variable, because the left variable before subtracting 1 to it is going to be the minimum value, so that this function returns true. And obviously we want to actually be able to place m balls. So instead of returning left, we're going to return left minus 1. So that if, for example, with distance 7, we cannot place all of the m balls, maybe for sure, with distance 6, we are going to be able to do so. Because 7 is the minimum distance, so that we cannot place m balls. As you can see, it gets accepted. So that's it for now, and bye.